Reading an electrocardiograph fascinates every medical student and practitioner. But what looks so simple and clear-cut in the books does not appear so when it comes to actual ECG reading in wards and clinics. This cassette aims to solve this problem by developing an eye to pinpoint the abnormalities and analyze them systematically. The cassette teaches simple things first and more complicated problems later towards the end of the cassette. So until you master the first 5 sections, do not view the last 2. Study each section individually through rewind and replay and master it before proceeding to the next. Now let us begin with an introduction to the PQRST terminology. This is the terminology used to describe the various waveforms of an electrocardiographic tracing. The first wave is the P wave, which represents depolarization and contraction of the atria. The next is the QRS complex, which represents the depolarization and contraction of the ventricles. It is followed by the T wave, representing repolarization of the ventricles. The repolarization of the atria is not recorded on the routine electrocardiograph. Sometimes another small upright wave follows the T wave and is termed as the U wave. Now coming to the QRS complex, the initial downward deflection of the QRS complex is termed as the Q wave. It may or may not be present. The first upward deflection of the QRS complex is termed as the R wave, and the downward deflection following the R wave is termed as the S wave. Sometimes there may be a second upward deflection following an R wave. It is termed as R dash wave. And if a downward deflection occurs after R dash wave, it is termed as S dash wave. Now we shall see a few QRS complexes to understand the terminology better. Here we see a small R wave and a deep S wave, an RS pattern. This is a tall R wave and a deep S wave, another RS pattern. And this is a tall R wave and a small S wave, again an RS pattern. You must have noted by now that prominent waves are written in capital letters and small waves in small letters. This is a R pattern with no Q wave, no S wave. In this complex we see a small Q wave, a tall R wave and a small S wave, a QRS complex. And in this complex there is only a downward deflection, no R wave. We do not know whether it is a Q wave or a S wave, so it is termed as QS complex. This is a RSR dash with a deep S wave. This is a RSR dash with a tall R dash wave. This is a RR dash pattern, and this is RR dash S dash pattern. Now we shall study the various intervals. The time from the onset of the P wave to the onset of the QRS complex is termed as the PR interval. It represents the conduction time from the atrium to the ventricles, from the onset of P wave to the onset of QRS complex. The time from the beginning of the Q wave to the end of the S wave is called the QRS interval. It indicates the time taken by the impulse to spread through the two ventricles. The time from the beginning of the Q wave to the end of the T wave is called the QT interval. It represents the total electrical activity of the ventricles. The line between the QRS complex and the T wave is termed as the ST segment, and the point of junction between the QRS complex and the ST segment is called the J point. The time interval from the apex of one R wave to the apex of next R wave is termed as the RR interval. RR interval is related to the heart rate or rate of ventricular contractions. The time interval from the beginning of one P wave to the beginning of next P wave is termed as the PP interval. The PP interval indicates the rate of atrial contractions. Under normal circumstances, the RR interval and the PP interval are both equal. In a normal ECG, the PR, ST and TP segments are at the same horizontal level and form the baseline or the isoelectric